This is the second of a series of videos I have about partial differential equations. So what we have here is a function z, and it is defined as cos of x plus 3y. So it's a function in two variables, cos and y. And what we're required to show is that the second derivative of y, or the second derivative of z with respect to y, minus 9 times the second derivative of z with respect to x is equal to 0. This is an example of a partial differential equation. This is, how should I put it, aimed at first year, second year undergraduate students, so it's not heavy going stuff. Just in case you're wondering. So what we're going to do here is just a quick remark. What we have to do is quickly talk about some differentiation, how to differentiate things. So we have to differentiate cos of x or sine of x, and or cos of x plus k, sine of x plus k. When k is a constant, when you differentiate cos of x plus k, you can just treat it as cos of x. Likewise, sine of x plus k, where k is a constant, just treat it as sine of x. This is from the chain rule. So essentially, we don't have to, when we're dealing with one variable, we could just treat the other variable as a constant and not have to worry about it too much. And again, if you want to try this out yourself with the chain rule, if you're not convinced by what I'm saying there, you could try to prove something with the chain rule. Okay, so what we're going to do is start with x. Okay, so let's have a look at this here. Cos of z. Let's put that in blue. Z or z is cos of x plus 3y. Okay. So what we're going to do is get the first derivative with respect to x of z, and that is minus sine of x plus 3y. And again, we don't really have to do anything with the 3y, just put it in there, it's just tagging along for the time being. And then the second derivative of z with respect to x, just derive that again. And that is sine. The derivative of sine is cos, so the derivative of minus sine is minus cos x plus 3y. Okay, so it's actually it's just the negation of the z itself. Okay, so that's one side of the equation done. Let's go back up here, just to sort of double check what we have to do. Minus 9 times that. Show that. So we're working on this side here. Okay, so let's just put in the minus 9 times that. Let's go back down. So 9 times second derivative of z with respect to x is minus 9 cos of x plus 3y. Okay, so that's one side of the equation done. Let's go to the other side now. And what we're going to start again, and this time we're working with respect to y. Okay, so we're getting the derivative with respect to y, and so essentially what we have to deal with here is cos of 3y. Okay, now these are some notes I made from a previous video, so I'll just go back down to them again. So particularly what we're dealing with is this one here. Oops, just put the x back in there. This one down here. Derivative of cos of ax is minus a times sine of ax. Okay, this comes from the chain rule again, these identities, but as far as I'm concerned, you can take them as things that everyone knows. So cos of 3x is therefore derivative of cos of 3x. That 3x will give you minus 3 times sine of 3x. Okay, sine of 3x is going to give you 3 times cos of 3x. Okay, so just make a little mental note of them because I'm going to use them very shortly. I'm not going to come back down here, so I'm just going to use both of those identities very shortly. So let's go back up here. So cos of 3y, the derivative of that, the first derivative of that is dz over dy first derivative of z with respect to y. That is minus sine of x plus 3y. No, it's minus 3 times, I should say. Minus 3 times that. Okay. And derivative of, actually I'll just double check that. Yeah, just got that right. Sorry for bouncing up and down there. Derive that again with respect to y. And we get just as a sort of quick remark, can treat this part as a constant. So we're just going to bring that down. So minus 3 times, and derivative of sine of x plus 3y with respect to y is cos of x plus 3y with respect to, it's 3 times cos of x plus 3y. Keep forgetting those constants. So what we have there is minus 9 times cos of x plus 3y. So that is the other side. And again, let's just go back to the equation that we have to prove all the way up to the top. So second derivative of z with respect to y. So let's put everything together down at the end. Just going to go new page here, and we'll wrap it up. So the second derivative of z with respect to y, minus 9 times second derivative of z with respect to x. That is equal to, let's just do this one here. That is equal to minus 9 cos of x plus 3y minus 9 times minus cos of oh yeah, we have to get a plus here actually. So it's minus 9 times. So sorry, I went over too quickly through my signs. So it is, let's just check the answer again. So it was minus 9. Okay, so minus 9 times cos of x plus 3y. Okay, so what we have here is, I got 9 times that earlier on. So that was minus 9 times cos of x plus 3y. Okay, now good, we're ready to go. You can tell pretty quickly now this is going to cancel out. So we have minus 9 times cos of x plus 3y plus 9 times cos of x plus 3y, and that cancels out. They both cancel out. Okay, so that's the job done. The key thing there is just getting the hang of the simple differentiation operations. So that's another partial differential equation job done.